Your AI assistant is brilliant and it is logged out of everything you actually care about: your notes, your database, your internal tools. Ask it to search your own files and it just apologizes. Today we fix that permanently. We are going to build an MCP server of our own from an empty folder to a tool Claude actually calls. By the end, you will have a working tool, a resource, a prompt, and a server your whole team can use. First question: why not just build a normal API? Because every AI app would need custom glue code to call it. MCP flips that. It is one open protocol that every major AI client already speaks. Write your server once, and Claude Code, Cursor, and VS Code can all use it with zero extra work. So, what is MCP really? Model Context Protocol. Think of it as the USB-C port for AI. Your server is a small program that plugs into any compatible client. The client discovers what you offer, and the model decides when to use it. You do not wire anything to a specific assistant ever. An MCP server can expose exactly three kinds of things. The first one is tools, which are functions the model can call like search or create. And the second one is resources, data the client can read like files or records. And last one is prompts, reusable templates you hand to the user. Three primitives, that is the entire mental model of an MCP server. And this is not a toy pattern. GitHub ships an official MCP server. Teams run servers that query their databases, search their docs, and file their tickets. Today, we build the most useful starter, a server over your own project nodes. So, here is the plan: a server called project nodes. It gets one tool that searches a folder of markdown nodes, one resource that serves a node by name, and one prompt that summarizes your week. Small, real, and genuinely useful by tonight. Setup is three commands with UV, the fast Python package manager. Create the project, add the MCP SDK with the CLI extras, and make one file called server.py. That is the entire scaffold. No framework, no boilerplate, no config maze. Now, the part that feels like a cheat code, which is obviously using the FastMCP. So you have to import the FastMCP, name your server, then write a plain Python function that searches your nodes. Put one decorator on it at mcp.tool. The docstring becomes the tool description the model reads, and that's it. That function is now an AI callable tool. Look at what you did not write. No JSON schema, no protocol handling, no request parsing. FastMCP reads your type hints and your docstring and generate all of it for you. The client sees a fully described tool which has names, parameters, and types. To run it, add one line at the bottom: mcp.run with transport stdio. Stdio means the client launches your server as a child process and talks to it over standard input and output. No port, no hosting, nothing to deploy. Perfect for our personal server. Now, the gotcha that kills almost every beginner server, which is on stdio, standard output is the protocol channel. One stray print statement and you have the corrupted JSON stream. The client just says connection failed, so never print. Log to the standard error instead, and it works fine. Before you touch Claude, test it properly. The MCP Inspector is one npx command pointed at your server. It opens a UI that lists your tools and lets you call them directly with real arguments. If search nodes works here and not in your client, the problem is the wiring, not your code. Always inspect it first. Now, how do you wire it into Claude Code? One command: Claude MCP add nodes. Then you run the command. By default, that is local scope, private to you and this particular project wherever you are running it from only. Pass scope user to get it in every project you own, or scope project to share it with your team. Then /MCP shows it as connected. And here is the payoff. Ask Claude, what did we decide about auth? It calls your search notes tool, reads your actual notes, and answers from them with the file it found, which means that you get source attributed response. 30 minutes ago, this model could not see your files. Now it queries them like a teammate. So project scope writes a file called .mcp.json into your repo. Commit it. Anyone who clones the repo and opens Claude Code gets a prompt to approve your server, and then they are connected to. So your custom tool just became team infrastructure through Git. Tools are actions. Resources are data. Add a second decorator. At mcp.resource with a URI template like notes:\name. Now, any note is directly readable by the client. No tool call is needed. The model reads it like a file. Third primitive, one more decorator at mcp.prompt. Write a function that returns your summarize my week template, and it shows up in the client as a reusable prompt. Your best prompts stop living in a text file and start shipping with your server. So far, all this is running on your machine. To serve your whole team from one box, change a single argument. Transport Streamable HTTP. Now your server listens on a real endpoint that remote clients can connect to. Same tools, same code. So you use stdio for personal ones and Streamable HTTP for shared. That is the whole decision in this stack. Once it is on the network, treat it like production. Put TLS in front of it and use OAuth for authentication, which the protocol supports natively. An MCP server with real data behind it is an API. Secure it like one. And if you build something genuinely useful, you can list it in the official MCP registry. It is a discovery layer like an app store for servers. It stores the metadata, what your server does, its tools, its transport, so any client can find it. Now the part most tutorials skip. In May 2025, researchers showed a prompt injection attack on GitHub's MCP server. A malicious public issue contained hidden instructions, and the agent followed them. After that, a private repo data leaked into a public pull request. The tools worked perfectly. The trust model was the whole. It gets closer to home. In April 2026, researchers disclosed an stdio command injection flow in the official MCP SDKs themselves, putting roughly 200,000 servers at risk. It was patched fast, but the lesson stands. Your server is part of an attack surface now. Harden it from day one. Least privilege, your node server gets read access to one folder, not your home directory. Validate every input. Pin your SDK versions so an update cannot surprise you. And treat anything a tool reads, files, issues, web pages as untrusted input, because the model will follow instructions hidden inside it. So let us recap the whole journey. One file and one decorator gets you a working tool. The inspector proves it works. Claude MCP wires it in, and .mcp.json shares it with your team. Resources and prompts round out the server. Streamable HTTP takes it remote, and the security checklist keeps it from becoming a headline. So your move, what you can do right now is that build the node server, and it is honestly under an hour. This week, commit .mcp.json and watch your team pick it up. And only then think about going remote. Start personal, prove it useful, then scale it. So everything you saw, the commands, the code shapes, the security checklist is in the description. If this saved you a weekend of protocol reading, and you know what the subscription button is for. Codecraft Studio, AI and LLMs for developers. I hope I have made you understand what and how you can build an MCP server. Let me know if you have any questions in the comments.